Okay, multiple alleles again here. Multiple alleles control intensity of pigment in mice. The gene D1 is full color, D2 is dilute color, so a little bit lighter, and D3 is deadly when homozygous. Okay? And order of dominancy, D1 is dominant over D2, which is dominant over D3. That's kind of a given because of the numbering system. But let's do a little bit of a legend just over here in the corner, just step one of all our problem solving strategies. So if I have a D1, doesn't matter what that other allele is, as long as I have a D1, that's going to be full, just full color. If I have a D2, doesn't matter what the other allele is, but it can be a D1, has to be either itself or something recessive. That's going to be dilute. And if I have a D3 in a homozygous condition, homo meaning the same, this is going to be dead. Okay, it's going to die. All right, so let's go through the question. Step one, step two, underline the parents. When a full colored male is mated with a dilute female, okay, that's our two parents. So let's put in their genotypes. Now, and then it talks about a bunch of offspring that they have, indicate the genotypes of the parents. So we can already tell that because we don't know the genotype of the parents, we can't do a Punnett square for this one. We're going to go look at babies. But let's put in what we do know and then an underline what we don't know. Full colored is a D1, but nowhere does it say if it's homo or hetero. So we put a line on the other one saying that we don't know what his other allele is. Crossed with a diluted female, D2, underline, because again, we don't know if it's homo or hetero. And then we go look at some babies here. Now, we don't look at any old offspring. We're looking for recessive babies. What is the most recessive trait? And that's any dead babies, right? Because we know their genotypes. If they're dead, has to be homozygous D3. So take a look. They had two full colored, one diluted, one dead. We don't care about ratios at this point because maybe we don't have to look at ratios. And if there was a dead baby, we know that this baby must have been D3. Well, where'd they come from? We know that if there's dead babies, both parents must have contributed this recessive allele for there to be any dead offspring showing up in that first generation. So just because of that, we didn't even have to take a look at these ratios. We just seen that there was a dead offspring, which is the most recessive trait. Both parents must have contributed. We now know what the genotypes are for both those parents. Okay, any issues, give me an email. Thanks, guys.